So we just talked about carboxylic acids, and we talked about how to IUPAC them and how to common name them, and this whole kind of system of valeric and caproic and butyric and propionic and acetic and formic, and then mixing that with alpha, beta, gammas. Are we even in the same class? I told you this was going to be a little bit different. However, once we learn a template, that template is applied to everything in type 1. What does that mean? Okay, well, the next functional group that we're going to focus on are the acyl halides. That's a C double bond O, and then on this side is a halogen, either a chlorine or a bromine most of the time. It doesn't have to be every time, but most of the time, these are the most common. Okay, so we're going to learn how to name these, just like we learned how to name the carboxylic acids. Okay, well, that probably means that I follow the same kind of rules that I've outlined already, except I don't really need to use the oic acids here. No. Oic acids are for carboxylic acids. That's why we name them the way that we do in the very end. So with this functional group, I need to modify the ending in a different way. And the way that we do that is oil. O-Y-L. Oil chloride. Or oil bromides, oil fluorides, if that's the thing, oil iodides, if that's a thing. But most of the time, they will give us chlorine or bromine-based compounds because those functional groups are electronegative, those functional groups are greedy, those functional groups make very good leaving groups, and they're not too overly reactive, and they're not too fat, like iodine is. It gives us a problem sometimes. So chlorine and bromide, or chlorine and bromine, chloride and bromide, are the Goldilocks of the halogens. So we're going to name these with oil, and then the halogen name at the very end. Now, we handle the cyclic molecules the same way, folks. We just modify the ending yet again, just like we did before with the carboxylic acids. So, I'm going to give you one video on naming acyl halides, and that's it. That's all that you need. Why? Let me give you an example. Let's say there's a C double bond O with a chlorine that is here, and then on this side, maybe a methyl group. Name this using the IUPAC nomenclature system. Okay, so what I do is I count the longest carbon chain, just like I did before. 2 carbons. Ethane. Drop the E and add oil, and then the halogen name. There you go. There's the IUPAC name for this compound, ethanoyl chloride. Okay, we have a common name as well. What's the common name? This is how we common name it. Do you remember the name for a 2-carbon chain using the common nomenclature? I hope. We just talked about it. It was acete, but instead of ic acid, because this is not a carboxylic acid, folks, so I can't name it ic acid, but what I can name it is YL from the oil group, just like we did oic, O-I-C. We kept the IC ending and put it into the common nomenclature. We'll do the same thing here. Oil will just end up with YL. That YL gets put into the name, so acetyl, and then we'll name chloride at the very end. And there is a common nomenclature example for that molecule. It's the same exact thing that we've done. The difference is the ending. It's a YL ending, not an IC ending in both of these cases. So ethanoyl chloride or acetyl chloride It goes by the same name. Either or is perfectly okay for this type of molecule. Quite honestly, in the world of carbonyls, common names are going to be used the most often. They are widely used. They are even stamped on the labels of the bottles that we have in the lab for the most part. They have been around for ages and they will continue to be around in the future. So there is a trend to push us in the IUPAC. However, this trend is a little bit more stubborn than some of the others, just because we have gotten so used to these common names in the carbonyl family that that's just what we prefer. We think that they're easier. It's something that we've always used, and it's going to be very hard to do away with. So IUPAC is preferred, but common name is really more common than the IUPAC name in this case. All right, so let's do another example. Let's do something like CH3, CH2, CH, up here at the top, CH3, then CH2, and then a carbon, double bond O with a bromide, Br. So we're going to do an IUPAC name and a common name. No rules, no tricks up my sleeve. We're going to use the same rules as we did before, but again, it's a modification of the ending. So IUPAC first. Longest carbon chain. Okay, well, let's number them. 1, 2, 3. If I go up, that's 4. I can do better. 4, and then there's a 5th. So 5 carbons in total. All right, so 5 carbons in total is a pentane, but I drop the E, and I add oil, and then the word bromide, because there's a bromine on it. So pentanoyl bromide. But that's not it, because at carbon 3, look at this, I have a 1 carbon substituent, and that 1 carbon is called a meth. So this is a 3-methyl pentanoyl bromide. That is the accepted IUPAC for that compound, folks. Now, let's take a look at the common name. No difference, no tricks, same as before. 1, 2, 3, 4, 5. All right, so 5 carbons. The common name for 5 carbons is Valer, V-A-L-E-R. So in the world of carboxylic acids, it would be called valeric acid. But we do not have a carboxylic acid. We have an yl bromide here. So we keep the YL, valerol, and then we'll add the word bromide onto the end. So valeryl bromide is going to be the name of that compound. But that's not it, because we have a substituent. It's the same as before. There's no difference. This is regarded as the alpha carbon. This is regarded as the beta carbon. So therefore, beta methyl valeryl bromide will be the name of this compound, the common name of this compound. So there you go, folks. 3-methyl pentanoyl bromide, or beta-methyl valeryl bromide. Say that 3 times fast. So hopefully you're seeing that there's no major changes here, right? We're kind of going with the flow. It's a modification of the ending. That is it. That's all that we're doing, which is good news for us, because that's less work that we have to memorize. Again, I hate that word. I hate memorize. You should be learning and adapting and using the procedure, not memorizing anything. But sometimes we have to. So we have to memorize the proper endings here. All right, so finally, I told you a little bit about a ring. So here is a ring structure. I'm just going to use the cyclopentane ring again. And then off of this is a C double bond O, maybe Cl. So how do we name something like this using IUPAC rules? There's no common name, but how do we do it using IUPAC? We do it just as before. We'll name the ring as a whole. So this is a cyclopentane. And then I add the word, not carbonic acid. We're going to use carbo, which means the carbonyl. And then we're going to add YL at the end. So in this case, it is carbonyl. and then we'll add the word chloride onto the end because there's a chlorine there. So cyclopentane carbonyl chloride. So what we do, if we have a ring structure, we will use carbonyl chloride every time to represent this piece. That's carbonyl chloride or carbonyl bromide. And then we'll name this just as it is. Cyclohexane, cyclopentane, cyclobutane, cycloheptane, cyclooctane. We name the entire ring as a whole. All right, so let's do an example, and let's look at this one. Draw the following. Pentanoyl chloride. Okay, seems easy enough. Let's see if there's any tricks. Pentan, pent, 5, not penthouse. Penthouse are sometimes good, but not here. 1, 2, 3, 4, 5. So pentanoyl means on this carbon I have a C double bond O, and then off of that carbon I have a halogen, and this halogen is a chloride. That's it. That's all there is. I'm just leaving off the hydrogens, but I assume that you know that they're there and how many are there. But that's all that pentanoyl chloride is. 1, 2, 3, 4, 5, and the chlorine at the end. Okay, well, what if we had to common name this thing? Let's just review common nomenclature again. It doesn't say that in an example, but let's do it. So 1, 2, 3, 4, 5. This is Valere, and it ends in a YL because that's what the IUPAC ended up using, because we are naming an acyl halide. Acyl, ACYL, so YL at the end. So an acyl halide ends in YL just like acyl does. So valeryl chloride is going to be the common name of this structure. Folks, I told you, simple, easy, breezy. That's all there is to nomenclature of acyl halides. Pretty much the same rehash over and over, except we've modified the ending to an OYL for IUPAC and just a YL for the common. The same thing happened in carboxylic acids. We used oic acid, and then in the common name, we simply just used the IC ending with the word acid that follows. So, pentanoic acid would be a 5-carbon chain like you see on the screen with an OH at the end. And then valeric acid would be the 5-carbon chain with the OH at the end. So, we're going to have to juggle. We're going to have to get used to these. Which ending gets used for which functional group? And I hope now you're making some connections. And the connections here are carboxylic acids, and we're going to keep adding on to this list. We'll end oic acid for IUPAC, and then IC acid for common. That we've taken care of. Check, check. The next one is the acyl halides. And as the name suggests, acyl YL. So it's oil and then the halogen name. So I'm just going to put halide there. Chloride, bromide, fluoride, iodide. And then for the common name, it's YL with the halide name attached. Do you see a trend? I hope so, because this trend is going to continue throughout the carbonyl lecture. It's just a matter of how on earth do we modify the ending to make it work. So this might seem like a lot in the beginning, and it is. But if we can kind of keep our heads straight and say, okay, what are they doing? Why are they doing what they're doing? That's the key step that many people leave out in organic. And now you can associate the endings to the name, because that is the name of the functional group, and that's very important for us to identify them, draw the structures, and kind of go on about our day. This way, all of the carbonyl functional groups don't just blob into one big lump sum. Okay? All right, so in the next video, we'll go on and we'll talk about our next functional group using carbonyl, and that is an acid anhydride. So we need to define what an anhydride is. What is it? How's it formed? Why is it an anhydride? You've seen it before back in general chemistry. And then we'll talk about how to name them using IUPAC and using common nomenclature. Stay tuned.